just had a really great question about finding the turning point of a graph. So this question asks for all sorts of things, but the last thing it asks for is the turning point. So let's say, for example, we would put this into the basic quadratic form, which is y is equal to ax squared plus bx plus c. So to do that, we just expand this out. So we're going to have x times x is x squared. 3 times negative 2 is going to be negative 6. And we've got a positive 3x and a minus 2x, which is just going to be plus x. So there we are. That's our equation. So now we're going to look at the coefficients of these things. Well, ax, bx, c. ax squared. What is a here? Well, a is going to be 1, so I'm going to write a equals 1. What's b? What's the coefficient of the b value? Oh, it's also 1, so b is also equal to 1. And c, what does c equal? C equals, negative 6. There it is. So they're the coefficients, and they're my a, b, and c values. Now, the importance of that in finding the turning point is we can use a little nice expression, which is the turning point is minus b over 2a. And we find that equation, or find that expression rather, if we have a look at the quadratic equation. So quadratic equation, of course, is x equals minus b over 2a, and then long things, plus or minus the square root of b squared minus 4ac. So b squared minus 4ac we call the discriminant, but the minus b over 2a is the turning point. So how does this play out? And how do we find the values we need for the turning point? Well, the turning point, in this case, is not so much the turning point, but the x value, and I'll put here x value of the turning point. So let's have a look at how that plays out. So here's my expression, or my equation in this case. I've got y is equal to x squared plus x minus 6. By the way, if I was to draw that nice and simple, it would be minus 3. Here's a negative 3. And we've got a minus 2 makes a plus 2 over here. And 3 times negative 2 is negative 6. So it's going to come down to here. And it's going to sort of kind of turn around. I'll try and draw this out roughly how it looks. This is not going to be that accurate, unfortunately. It's going to come down here. It's going to turn around like this, head back up like that. Now, I've kind of got that. I'm pretty pleased with it, actually. So this point here, the intercept is negative 6. And the negative 6 comes from 3 times negative 2. Yeah, or if you like, let's go with that. 3 times negative 2. All right. Now, the actual turning point, though, because parabolas, of course, are symmetrical. And they're symmetrical around whichever the mirror line would be down here. And mirror line, of course, is going to be halfway. And if you want to find halfway, you could just say, how far is it from here to here? Well, it's got 1, 2, 3, 4, 5. Half of 5 is 2.5. So if I just went 2.5 from here, 1, 2.5, or from here, 1, 2.5, that would be the point there. But let's prove that. So let's use the turning point, the x value of the turning point, I should say, is minus b over 2a. So let's do that now. So what was negative b? Well, b is 1, so I'll put x val of turning point is, and I'll put minus b over 2a. Now let's populate that with the information we have. So b is 1, so it's going to equal minus 1 over 2 times a. What's a? A is 1. So negative, well, that's going to equal negative 1/2. So we can see here, and that is the value here. So the turning point value is, that's going to be x is equal to negative 1/2, or negative 0.5. Now that's the x value. So we found the x value of the turning point. Now we want to find the y value. What we do is we take the equation as it is, and we substitute the x value back into it. So here we go. So we've got y is equal to x squared minus x minus 6. We know what x is. X is going to be negative 1/2. I'm going to substitute that into here. I'm going to substitute that into here. Let's see how that plays out now. So I've got negative 1/2, or negative 0.5. I'm going to square it, minus negative 1/2. There it is. Minus 6. Well, negative 1/2 squared is negative 1/2 times negative 1/2, which is positive 1/4. And we've got, what have we got here? This is negative 1/2, which is positive 1/2. And we've got a minus 6. Now, so I've got a half, I've got a quarter minus a half, minus 6. So let's just do that on the calculator. Let's have a look. So I've got a quarter, minus 1/2, minus 6. And that's 25/4. What's 25/4? That's negative 6 1/4 is equal to negative 6.25, or 6 1/4. Now, where is negative 6 1/4? So what it's saying is we've got our negative 1/2 value, but this actually goes down beyond 6. It actually goes down a little bit lower, yeah? Actually, not quite that low. It goes down a little bit lower, it goes down to there. There's 6. It goes down just below 6. And so the value here, this point here, is going to be the turning point. And the turning point, not just the x value now, but the whole coordinates of that. So here it is as an ordered pair, is going to be negative 1/2 is my x value. So I'll put negative 1/2, comma, negative 6 1/4. Negative 6 1/4. And there is the value of the turning point. Hope that makes sense.